Okay, so this is the foundation paper question number 4. The pie chart shows the percentages of background radiation from various sources for an area of Cornwall in the UK. Use the following information to complete the key for the pie chart. So around 50% of background radiation comes from radon gas. So if we have a look at the pie chart, we can see that 50%, which of course is half, is represented by this area here labelled D. Okay, so the radon gas is letter D. Then it says 25% comes from ground and buildings and medical together. So 25% is a quarter, and we can see that area A is a quarter of this circle. So that must be this one here, grounds, buildings and medical. 15% comes from cosmic rays and 10% comes from food and drink. So if we take the only two parts left, we can see that B is bigger than C. So B must be the 15%. So B is cosmic rays, which leaves us with C as food and drink. Okay, so just a matter of working that out from the diagram there, really. It then goes on to ask us, to tell us that the background radiation from radon gas in Mid Wales is smaller than in Cornwall. The background radiation from all of the sources remains the same. Alan states that the pie chart for Mid Wales would be the same as the one above. Explain whether you think Alan is correct. Okay, so if the background radon for gas in Mid Wales is smaller than in Cornwall, and if we had a pie chart of that, then the amount due to radon gas would be less than 50%. It might look something like that. Okay, and then the other, proportionally, the other three would look something like that. Okay, so Alan sadly is wrong. Okay, so Alan is wrong because the amount due to radon gas is smaller. And that would change the shape. So we'd still have a D, we'd have an A, we'd have a C, and a B, but the proportions would be slightly different, okay, because the amount due to radon gas is smaller. Okay, part B tells us that the isotope of polonium-210 has a half-life of 140 days. So there's a lot of information in that first sentence that you do need to understand what that means. So an isotope is an example of an element with a certain number of neutrons in its nucleus, okay, and that affects the number here. Okay, it's not that isn't the number of neutrons, it's the number of neutrons and protons, but it affects that number. And it has a half-life of 140 days, so you need to understand that half-life is a time period that where half of the radiation will disappear, or half of the polonium-210 will disappear, okay, due to radioactive decay. It's a source of alpha radiation. Okay, so alpha radiation is where the helium nucleus is given off. Okay, that's an alpha particle. It tells us that 200 grams of polonium-210 is stored in a locked cupboard. The mass of the polonium-210 halves in 140 days, which is basically telling you what half-life means. Okay, state one other quantity that halves in that time. Okay, so it's the radiation count due to alpha decay. Okay, so if you measured how much radiation was being given off on day 1, and let's say that was 100 counts a second, if you went back 140 days later, you would find it was 50 counts per second. And if you went back another 140 days later, you would find that it was 25 counts per second, because half-life means the radiation halves every period of time. Okay, so in this case it's 140 days. So with that in mind, complete the table below to show how the mass of polonium remaining changes with time. So on day 0 or day 1, if you like, 200 grams as described in the question there, so 200 grams of polonium-210. If you went back after 140 days, okay, so sort of 6 months, you'd find there's only 100 grams of polonium left. If you went back after another 140 days, because each of these is 140 days gap between them, okay, then you would find that it's not 0, it's actually 50, because every 140 days, half-life means exactly that, half of it disappears. And another 140 days later, you would find there was 25 left. So every 140 days for this particular radioactive isotope, the amount of polonium-210 halves. So 200, 100, 50, 25. Okay. And then the final part of this question is a lot of crossover with chemistry. Okay, so if you can understand, you can read a periodic table, then you should be able to answer this question. The only difference is this word here. Okay, so it says complete the following table given the numbers of particles in the nucleus of polonium-210. Now, the word nucleons tends to be only in physics, but what it means is anything in the nucleus. Okay, and if we look at the information in the question, the stuff in the nucleus are the protons and the neutrons, and they have all got a mass of 1, therefore they give the element mass, so it's 210. The number of nucleons is 210. Okay, the number of protons is the atomic number, also known as the proton number. So that's 84. Okay, and then the number of neutrons is the takeaway. Okay, it's the number of nucleons take away the number of protons. Okay, so we'll do a quick takeaway. So that's 6, and then that's 2, that's 126. Okay, so 210 take away 84, 126. So that's the number of neutrons.